Hello and Assalamualaikum. This is Group 3 for Group Project Electronic Communication System BNR 20903. For this project, we choose to simulate a bandpass filter circuit. First and foremost, for introduction, electronic circuit must perform two different functions. First, they must respond to desired signal, and second, they must reject undesired signal. Our world is full of variety of interfering signals, all of which are grouped under the headings electromagnetic interference EMI or radio frequency interference RFI. Filters come in a variety of types, but perhaps the most useful way of categorizing them is by passband. Passband like low pass, high pass, band pass, and notch filters are the basic classes of filters. Bandpass filter is a device that passes frequencies within a certain range and rejects alternate frequency outside the range. Bandpass filters are widely used in wireless transmitters and receivers. The main function of such a filter in a transmitter is to limit the bandwidth of the output signal to the band allocated for the transmission. This prevents the transmitter from interfering with other stations. In both transmitting and receiving applications, well-designed bandpass filters having the optimum bandwidth for the mode and speed of communication being used. This will maximize the number of signal transmitters that can exist in the system, while minimizing the interference or competition among signals. Moving on for the methodology, we use resources from primary source and secondary sources as guide to collect the data. We were using Proteus 8 Professional to carry out the design and simulation of the RC bandpass filter circuit. The operation steps to work on this application are handy since the multitude of options are provided for the inserting elements into the circuit from the application library. Frequency response graph is also used for the output frequency to display the output of the RC bandpass filter circuit frequency. Finally, circuit analysis based on the output of the simulation is carried out. It discusses the role of the elements involved in the circuit, and for the Q factor, resonant frequency and output frequency bandwidth are calculated using a suitable formula from the output frequency response graph. Moving on to the result and discussion. Figure 2 shows RC bandpass filter circuit diagram. In this project, we will be using simple elements component to stimulate the circuit, which is capacitor and resistors. To illustrate the circuit, one capacitor C1 with 1 nanofarad placed at the initial of the circuit and one capacitor C2 with 1 microfarad located in the middle of the RC circuit. Next, there are 3 resistors in the circuit, 2 resistors R1 and resistor R2 with both 1K ohm set at the middle of the RC circuit between capacitor C1 and capacitor C2, and resistor RT with 10K ohm that act as load located at the end of the circuit parallel with capacitor C2 as shown in figure 2. Based on the figure 2, 1 nanofarad capacitor C1 and 1K ohm resistor R1 at the front part of the RC bandpass filter circuit were part of the high-pass filter circuit diagram as shown in figure 3. A high-pass filter thus is at opposite of a low-pass filter, which is to offer a easy passage of a high-frequency signal and difficult passage to a low-frequency signal. The capacitor impedance increases with the decreasing of frequency. The high impedance in series tend to block low-frequency signal from getting to load. Meanwhile, the 1K ohm resistor R1 and 1 nanofarad capacitor C1 at the middle of the RC bandpass filter circuit, figure 2, are the components of the low-pass filter. A low-pass filter is a circuit that offers an easy passage to low-frequency signals and difficult passage to high-frequency signals. The capacitor impedance decreases with the increasing of frequency. The load impedance in parallel with the load resistance tend to short out high-frequency signals, dropping most of the voltage across its resistor R. Next, we have input signal waveform. The input signal shown at figure 5 is a sinusoidal waveform. The waveform generated in this state due to the alternative current AC delivered by the power supply. The AC waveform will constantly change its polarity every half cycle, alternating between a positive maximum value and a negative maximum value, respectively, with regards to time. The waveform amplitude is set at 12V and the frequency is set at 1 kHz. Next, we got figure 6 of output signal waveform. As we can see, the circuit has successful pull out and output, which is the band pass filter signal. The band pass filter signal that presented at figure 6 consists of two parts, which are the high pass filter signal and low pass filter signal. Figure 7 is the high pass filter signal from the figure 6. And in figure 8, we can see low pass filter output signal waveform that have been mentioned in the figure 6. We further analyze the circuit by calculating the kernel frequency F, resonant frequency Fr, and the quality factor Q. The kernel frequency for this circuit consists of two parts, which are frequency for the high pass filter and low pass filter. To get the kernel frequency, we use the formula of F equals to 1 over 2 pi RC. Using the values given, we insert into the formula and we got for the high pass filter frequency with 159.155 kHz, and for the low pass filter frequency we got 159.155 Hz. And for the resonant frequency, using this formula, we got 5.033 kHz. And for the last calculation, the quality factor can be calculated by using the formula of Fr over bandwidth. We can get the bandwidth by searching the differences between the Fk and Fl. And we got 158.996 kHz. Insert the values into the formula, we got the quality factor T1.955. The conclusion we can get from this project is a simple passive low pass and high pass filter may be simplified by connecting a single resistor and a single capacitor in series. Band pass filter allows the signal with specific frequency range or band and attenuate the signals which frequencies are outside of this band frequency without distorting the input signal or introducing extra noise. In band pass filter, there are low pass and high pass filter. Low pass filter is used to isolate the signals which have frequency higher than the cut-off frequency, and high pass filter is used to isolate the signal which have frequency lower than the cut-off frequency. Combination of high pass and low pass filter makes band pass filter. From the result and discussion, we have shown circuit diagram that contains the circuit of high pass and low pass filter. As shown, the first cut-off frequency is from a high pass filter and the rest of it is for low pass filter. In our project, we use 12V as input, 1 kHz as input frequency F in, and 1 kHz as well for output frequency F out. When on the circuit, the value for high pass filter with lower cut-off frequency is 159.155 kHz. The value for low pass filter with higher cut-off frequency is 159.155. And that is all for project band pass filter circuit from Group T. Thank you for watching.